System identification video. Hi, we are from Cyclone UAV and this is our system identification video. In this video, we showcase our UAV overall system operation and explain how our team approaches the 3 missions for the Technofest Fighter UAV competition. The UAV airframe we use is the Sky Surfer. It is extremely lightweight, affordable, and meets all the electronic requirements for each mission. The total flight time for our UAV at maximum takeoff weight is 20 minutes, with all cameras and electronic functioning optimally. The takeoff weight of our UAV is below 1 kg, thanks to the heavy processing being done on the ground. This makes our UAV more agile and durable compared to others. Here are 3 unique features of our UAV that we'll bring to the competition. First, the entire system is designed to be affordable and cost-effective. We use the lowest spec equipment while still being able to perform our mission better than the rest. This project also aligns with our team's main goal for participating in this competition, which is to create an educational module. Students can customize and modify our system based on various purposes and applications. Lastly, our approach to all missions is direct and straightforward. We choose the simplest method available to meet all the mission requirements without needing to implement novel or high-level algorithm or software. Here is the overall test system setup. It consists of 2 planes, which is chaser and leader, a custom DIY antenna, and a Jackson Nano with CSI camera and HD FEV monitor receiver. The setup is proven to perform all missions effectively and at lower cost. Mission 1. There are 5 main steps in our approach to Mission 1. We start by accessing the competition server to obtain live enemy data GPS. This data stream is extracted and converted into live enemy GPS data format via a script, which is then fed to our UAV autopilot. Next, our UAV is switched to guided mode, which activates the combat mode. The UAV races toward the transmitted live enemy location at full speed. Since our UAV is extremely light, we can compensate for any data transmission delay and closely follow the targeted UAV. Our UAV continuously follows the enemy at a very close distance with an HD DJI FPV camera transmitting a live stream of the onboard video to ground station. At the ground station, the HD DJI camera video is used as the main input for detecting and tracking the enemy UAV. The system continuously scans for the UAV and once successfully locked for 4 seconds, our program automatically generates all related information about the lock-on data. After the lock-on data is confirmed, we switch another UAV to continue the mission. Since we cannot simulate the competition server in real time, we built and designed a custom GPS tracker. This GPS tracker functions to continuously transmit the lead plane's GPS data to the chaser plane's autopilot. Mission 2. For Mission 2, we have set up a custom flight plan uploaded into our UAV autopilot. The flight plan is designed to include QR code coordinate as a last waypoint. The kamikaze mission can be triggered by switching the autopilot to auto mode. This will make the UAV start its approach to designated QR code coordinate and perform a dive from high altitude. At the same time, the ground station program will switch from the combat script to the kamikaze script, which will capture the video stream and try to log onto the QR code data. Once it successfully logged onto the QR code, A custom script will automatically generate a related log-on data, such as the timestamp and the code stored inside the QR code. Since the QR code coordinates are our last waypoint mission, our plane will immediately land afterward. In other words, we will only trigger the kamikaze mission in the last 3 minutes of the competition round. Entry. For defense zones avoidance mission, we start by keying in and understanding the fly region and possible no-fly zones in our autopilot system before the competition round. We use the fence feature in our autopilot, which include both inclusion and exclusion fences. These fences run continuously in the background during mission 1 and 2. If a fence is breached, our UAV will trigger the return to launch, which is RTL, command away from the restricted zone. Once we observe that our UAV is at a safe distance from the fence, we will switch it back to the guided mode to continue mission 1 or auto mode to initiate mission 2. For safety and clearance purposes, the actual defense zones is drawn 30% larger than the zone provided by competition organizer. This allows our plane to have the necessary space and distance to maneuver away from the zone without accidentally re-entering it.